Vibratory feeder bowls are a mystery to many. Because they're so poorly understood, they often don't run as well as they should. The truth is that they're really very simple. Once you understand the basics, you'll be able to keep them quietly humming along. Hi, I'm John Henry from Frayne Industries. I wrote the book on packaging machinery, and this month I'm going to explain how vibratory bowl feeders work. If you've ever pushed a kid on a swing, you know something about pendulums. One of the things you know is that if you push lightly at the very top of the arc, it takes almost no effort to keep the swing going all day long. Push before or after the top of the arc and you have to work at it. Even little kids grasp this idea instinctively. The vibratory feeder is a pendulum. It may not look like one because it's upside down and mounted on springs, but it obeys the physical laws of pendulums. If you understand pendulums, you'll understand vibratory feeder bowls. There are four main components to a feeder system. The reaction mass is a heavy, usually cast iron or steel base. It needs to be heavy so that it does not vibrate. Rising vertically from the base are springs, usually at least 3, but often 4 or more. These are typically spring steel or fiber strips. These springs support the feeder bowl and allow it to rotate back and forth slightly. Note that they're angled against the direction of flow. Finally, the solenoid magnets act against the springs to rotate or vibrate the bowl back and forth. The amount of rotation may vary from thousandths of an inch for smaller bowls to an eighth of an inch or more in larger ones. When the solenoid is activated, it pulls the bowl backward. The spring angle adds a vertical motion to the horizontal motion. As the bowl track drops down and back from the parts being fed, the parts move, mostly vertically. When the solenoid releases, the springs move the track up and forward, giving the parts a mostly forward motion. Repeat this sawtooth motion 120 times a second. The parts will move along the track pretty briskly. Some smaller systems use a single solenoid to pull the bowl down vertically. Vertical or horizontal solenoid, the twisting motion of the bowl is the same. In the US, AC power is standard 60 Hz, which means 120 pulses per second. Many other countries use 50 Hz, giving 100 pulses per second. Now, remember what I said about the swing? The frequency you need to push at is determined by the length of the pendulum and the weight of the kid. Ditto the bowl feeder. The bowl has a natural vibration frequency determined by the weight of the bowl and parts and the length and stiffness of the springs. This is where the concept of tuning comes in. The solenoids are going to pull the bowl 120 times per second. If the bowl wants to vibrate at some other frequency, the pulses will not be in sync and the bowl is said to be out of tune. An out-of-tune bowl will not feed smoothly, it'll be noisy, and it'll consume more power than it should. It won't feed, and you may be left wondering why. Tuning is accomplished by adjusting the weight of the bowl and the spring stiffness so that its natural frequency is 120 pulses per second. Alternately, a variable frequency controller with an accelerometer can be used to match the power and bowl frequencies. When your feeder is in tune, you'll hear that sweet, sweet music of productivity. You know what else is sweet? Renting or buying from Frayne. You can get a machine or an entire line delivered on a schedule that'll make you feel like dancing. Rent the equipment and it stays off your balance sheet. Everybody gets happy feet. Visit Frayne online at www.fraynegroup.com or visit their plant in Carroll Stream, Illinois, minutes from O'Hare Airport. Let them show you what they can do for you. I'm John Henry, and I'll demystify another machine for you next month. Thanks for watching.